Hello, everyone. Welcome to this webinar to introduce the new MarForm MMQ 500. We're excited to have the opportunity to share this with you, and thanks for taking the time to look at this with us today. Here's the new system and some of the key features. This slide is kind of the Cliff Notes version of the presentation I'm going to make today. This is a new system which extends the MMQ product line. It doesn't replace something that previously existed. It's a new product and an extension of the product line, kind of at the high end of the product line. One of the key features is the speed of the system when aligning the part. Most of you that have used form testers know that the first thing you do in a measurement process is to align the axis of the part to the axis of rotation of the machine using a centering and tilting table. In this system, we feature an all-new design for the centering and tilting table, which dramatically speeds up this process. So while this is just the alignment and not the measurement, the total cycle time to complete the measurement process is significantly decreased. In a production setting where you're trying to measure a lot of parts per shift or per day, this can be a really big deal. Additionally, this is a new product at the high end of the MMQ line and features better specifications in numerous categories, making it more capable than all the other models. And here we see the whole product family. And people often ask, how would you describe the product line and what separates each system from the next? I would usually explain that as you move from left to right in this picture and move from the MMQ 100 and now to the new MMQ 500 on the right, there are several key things that change. The most visually obvious difference is that the machines get larger and have a bigger measuring volume and therefore can handle larger parts. But there are other very important differences. You get increasing levels of automation as more and more axes are motorized to allow CNC operation. Also, more and more axes become high precision axes capable of performing a measurement while moving the probe system along that axis. For the simpler machines, the axes just allow the probe system to be repositioned such that another axis on the machine that has measurement capability can be used to do that measurement. So you get increasing size, but also increasing automation, increasing precision, increasing number of measuring axes. These are a little hard to see with so much on one screen, and even the size differences between the machines is hard to see. So let's take just a little closer look so we can see how the MMQ 500 complements the existing line. We'll start with the MMQ 100. It's got just one measuring axis, the rotating spindle of the C-axis. It's got manual movement of the X and Z axes. These are positioning only axes. And the centering and tilting table is also manual. It's a great system for measuring any feature that only relies on a precision rotary axis for the measurement, such as a roundness or a runout, maybe concentricity. You can do analysis of the data for the harmonics, what many would call an FFT or fast Fourier transform, and many other specialized analyses as well. We offer things like special software packages to measure the armatures and stators of electric motors. That is a great special application that only relies on the C-axis, so we can do a lot of things with this kind of a system. It's important to note that it's the only motorized axis that is the C-axis, and it's the only precision measuring axis. This little guy weighing in at under 65 pounds is a great system to be put on a bench in the shop floor and can relatively easily be moved should it be necessary. We see the specs down there in the left hand corner, so up to 20 kilograms of payload, Z-axis range of 300 millimeters and a maximum part diameter of 210. We go up to our next step in the product line, move up to the MMQ 150 and 200. We see that we get slightly better performance specifications for the C-axis, and now both the X and Z axes are motorized. X is still a positioning only axis, but it is motorized. Z is a precision measuring axis now, so measurements requiring both the C and Z axes to be measuring axes are now possible. Most common example of some time when you would need this would be something like a cylindricity measurement. where it isn't enough to be able to measure each roundness profile by itself, but you have to be able to relate all of them to each other. The precision z-axis allows you to do that. Just overall, the level of automation possible is much higher with the motorized axes. You can do programs that perform the entire measurement for you. The only axes that you need to manually move here are on the centering tilting table. So once you get the alignment complete, the program will run by itself and you don't need to have any operator involvement. One key difference between these two is that the MMQ 200 allows a motorized gauge head. This lets you have program control of the probe position as well as all the other motorized axes. So for example, changing measuring directions from an outside diameter to an inside diameter can be automated, or changing from a radial measurement on an outside diameter to an axial measurement on a shoulder is also possible via CNC control within a program. In addition to making it possible to move the probe tip in space, it makes it possible to put multiple tips on the same probe. Many of you are familiar with CMMs, and you might call this sort of a thing a star probe, and those are possible on our MMQ 200 with the CNC gauge head. With this capability, we can do things such as putting a ball tip for form measurement on one end of a probe and a diamond tip for surface roughness measurement on the other end. And as part of the measuring program on the machine, we can switch automatically between them as needed by rotating the probe 180 degrees. All the rest of the systems we're going to look at, all the way up to our new MMQ 500, feature this motorized gauge head. And before we leave, we look at the specs. We see, a little better specs on the C-axis in addition to the motorized head. All things that are featured here. The next step up is really a family within the family. It's the MMQ 400, but the MMQ 400 is really a bunch of different sized machines. You compare it to the little MMQ 150 and 200s. It offers z-axis heights in 350, 500, or 900. So not just just 300 or 250 like the last two machines. So much bigger there, and the maximum diameters of parts up to 530 millimeters. So again, much larger. Now all three of the axes, the C-axis, the X-axis, and the Z-axis, are all motorized, all measuring. So we've added another measuring axis here. Another feature is the ability to get it with a tailstock. If you have, for some of these really long parts, if you want to hold a part between centers rather than holding it in some kind of a fixture chuck or something like that. And having all of the axes be measuring axes allows you to measure really the most complex kinds of forms that you can on any system. Now, you saw when we looked at the whole product line that the MMQ 400 and the MMQ 500 kind of look like they're in the same size class, and they are. And the MMQ 500 kind of fits in the middle of the MMQ 400 size class, but there's a lot of important differences. So let's take a look at the MMQ 500 and what some of these important differences to the rest of the MMQ line are. So as I mentioned before, this is a new product that is added on to the high end of the line. It doesn't replace one of the old ones. Right now it's available in one size only, a 470 millimeter Z-axis and 280 millimeters in X. All of the axes are precision measuring axes. The key new technical feature that enables a lot of the capabilities of the machine is this new centering and tilting table. It's much faster. We're going to see a video in a couple of minutes of that. It can adjust all of the motors that are in there to do the tip and tilt and centering in X and Y all simultaneously. It has more range in X and Y. It has more range in the tilting than any of our other machines. And you can handle higher loads, up to 80 kilos. On the previous slide, we saw, I didn't mention, but the MMQ 400 is up to 60 kilograms. And it has a little bit larger table, so it can handle bigger parts in that sense as well. To compare it spec-wise to the MMQ 400 to see how it is a little bit a higher end machine than that, we look and we see that one of the most impressive things is the MMQ 400 was already good in terms of the roundness error in the C-axis, but the MMQ 500 is even better. So this is that the roundness error you see in the table is 20 nanometers or 0.02 microns, plus a factor per millimeter in height that you go up from the table. This is a phenomenon known as a coning error. And the idea behind that is the rotary table is supposed to turn around a perfect axis in space. And always there's some little error, and you want to minimize that error. And if that axis also wobbles a little bit, as well as runs out a little bit, the wobble causes you to have the effect that the higher you go away from the table, the more of that error you see. And so on the MMQ 500, that coning error has been cut in half. The table we mentioned is a little bigger, has a little more capacity in terms of an 80 kilo payload, has a bigger range to be able to center and tilt in, both in the X and Y centering as well as the tilting. It's got better straightness specs on the Z-axis and X-axis straightness, and additionally a slightly better spec on the parallelism between the Z-axis and the rotary axis of the C-axis. That's especially important if you're doing measurements of things like cylindricity, where any error in that parallelism can creep right into the cylindricity values that you measure. Also, it's important that you can not only achieve this once when you calibrate it, but that it holds this level of parallelism. And with the MMQ 500, we do that. If we look at this, we see a picture of the MMQ 500 in what we call a factory enclosure. I'm going to show this to you as an option. One we're recommending with the MMQ 500 because we think with the increased speed, one of the most typical places this will be used is for production environments where we're trying to measure a lot of parts per day. You know, if you're putting a machine in a lab and bringing in a part every hour or two, the speed isn't such a big benefit on the MMQ 500. Now, the increased specifications, the tighter tolerances, those might be a big deal, but the speed will really come into play in the production environment. With this enclosure, you see built-in touchscreen. All of our software is touchscreen capable, and so it's pretty easy to operate in the production environment. Open the door, put the part in, close the door, hit the choose the program and hit start on the touch screen and walk away, because the centering and tilting is automated and all the measurement is automated, so it'll run without any operator intervention needed. Like all of our products in the MarForm family, we can incorporate things like signal lights, the red, yellow, green lights on top of the enclosure here that can be programmed to mean certain things depending on what that should mean in your production environment. Also, we can use the optional remote monitoring software where all of the Mahr machines can be networked to a central location where the status of all of them is monitored. So you know which machines are running, which machines are sitting idle, which machines last part measured out of tolerance, you know, all of the capabilities to control all of the Mahr machines throughout your facility, your network. And one of the features that's often overlooked is that with all the MarForm testers, and the MMQ 500 is no exception, the mechanical bearings require no compressed air supply. You might hear that mechanical bearings are not as good as air bearings from the guys who supply only air bearings, but look at the specs of the bearings and, you know, make the decision for yourself. But the mechanical bearings are very robust, very rigid, have really long life and don't require the compressed air supply, which is a real advantage. So one of the things that we wanted to take a look at, I've linked up a video here that is available on our YouTube channel, and this will show you a comparison between sort of the old classical form tester and the MMQ 500. You can go to our channel and look at this and other videos yourself if you'd like. What you'll see in this video is you'll get to watch side by side the alignment process, the MMQ 500 on the right, and a traditional form tester where we take a roundness trace on one place, then go take a roundness trace on the other, and then we align the part, and then we take two more roundness traces. On the MMQ 500, you saw it just went up and down the part, moved all the motors simultaneously, and completed an alignment from 1 millimeter to 1 micron in less than 60 seconds. Now, all of this was at time-lapse photography, of course, but all at the same sped up rate. So we went from over 4 minutes to under 1 minute. So that's the key difference. So no discussion of the capabilities of the MMQ 500 would really be complete. No discussion of any MarForm tester would be complete without taking a look at the software that we have available for it. We have our Marwin software platform on all of our Mahr systems. MarForm is no exemption from that. It's one platform, one suite of tools that's used by all the systems to operate the machines, collect and analyze the data, present the data to the user, or send it to some type of archive or database. All of the steps in the measurement cycle are carried out via our Marwin software. Having everything on one platform makes it easier for the user to understand and to move from one system to another. And that reduces the learning curve where multiple machines are in use. That's really the benefit for the user standing in front of the machine. But it actually does a lot more. It means that it's quite easy to do things like use the roughness analysis software on a form tester, for example. Provided the form tester is mechanically capable of getting data suitable for roughness measurement, the software is ready. What I mean by that is if the form tester is using a probe with the right stylus tip radius, has a probing force low enough for roughness, has a point density high enough for roughness, etc. If those kind of conditions are met, then it's easy to do with the software because it's all in the same platform. This is true of the new MMQ 500 as well as the 400 and the 200. Any of them that are using the CNC probing system can incorporate things like the roughness measurement, as well as many other types of specialized analysis. Like with most of our Mahr systems, the form tester software comes in 3 basic levels: easy, advanced, and professional. And you can really use any of them on any of the systems. And the programs created by any of them can be run by any of the systems and be run by any of the other packages because they're all part of that same platform. The last bullet point there is you can see which levels come standard with which systems. With the new MMQ 500, it's delivered with both easy and AdvancedForm. We'll take a quick look at them, each one in turn. So this is EasyForm. EasyForm is intended to make all of the measurements as simple as possible. When you think of a typical user walking up to one of these form testers, you might think of them coming with a part in one hand and a print in the other, let's say. And the goal, the reason they're there is to measure the form features and see if they conform to the print they got. So let's imagine the user puts the part on the machine. The first thing they want to measure is a roundness somewhere on the part. How do they know they want to do that? They looked at the print and they see the call out for roundness and a tolerance and they want to check it. With EasyForm, you do the same thing. It's the same logical process. You look at the screen, you see the roundness call out. It's a touchscreen application. So you simply point to it, click it, enter the tolerance, and press start to make the measurement. It's really as simple as that. With With EasyForm, it's as simple as choosing the features you want to measure, put the probe on the surface where you want to make the measurement, and press start. We don't talk about traditional programming with EasyForm. You're just measuring features, one by one, measuring features. But of course, as it turns out, the system has the capability to remember all the features you measured and the movements you made in between them. And so this can be saved as a program. But the key is the user doesn't have to think like a programmer. You don't have to turn employees into programmers to get them to work in EasyForm. You don't have to think about coordinate systems and things like that that a traditional programming environment requires you to do. You just measure features, and if you choose to do so, you save it as a sort of teach-in program. So that makes it really, really simple. And this is AdvancedForm. So there are some applications you may want to be able to do more than you can do with EasyForm. Sometimes you just want to do programming things like a programmer, like you want to be able to duplicate measurements by cutting and pasting and then editing, so that it's the same measurement but at a different measurement location. You can do that in AdvancedForm, but of course, EasyForm with its non-programming way of thinking doesn't let you do that. AdvancedForm lets you do all those kinds of things, but it's still not, it doesn't look like old-fashioned coding. It doesn't look like a text-based language. It's not a C or BASIC or Python or something like that. It's icon-based. You add steps to the program by clicking on the icons. Each icon has a data input wizard that opens when you click it and lets you put in specs like tolerance, the X and Z and C locations of the measurement, all of that kind of stuff. And it lets you use coordinate systems. You can create a coordinate system, a part coordinate system on the part, and then use the simple distances off the print as the coordinates of where to be measured. So it is programming, but still at a reasonably simple to use level. I would say something like 95 to 98% of our customers use either Easy or AdvancedForm. A lot of users go back and forth between them. They have a few people who like to think like a programmer and will create more complex programs in AdvancedForm, but the majority of the users just gravitate towards EasyForm. It really depends on the location and the type of customer you might be, but those things are all possible. The final thing we'll take a look at is ProfessionalForm. Now, we don't have very many customers who use ProfessionalForm because it is that script level programming. It looks like writing code. We have a few customers who do it, and they do it kind of for the same reason that our application engineers who use it all the time like to use it. It's because your abilities are almost unlimited. Once you kind of know how to do it, you can really imagine doing anything. The sky's the limit. And so it is really powerful, but it's the sort of level of coding that very few people want to learn. Just mention it because it is available, it's possible to do, and it really increases the capabilities of all of these systems, including the MMQ 500. And it's something that if this is the sort of thing that you look at and say, I don't want to do, no way, no how, but I have some need to do some special things that wouldn't be in a standard kind of capability of software. That's something we're happy to do, have our application engineers do for you and create for you. And then, as I mentioned before, any of these programs created in different packages can be used in other packages. So if you're comfortable using EasyForm, but you need something special from ProfessionalForm, we can create that and we can let you use it in EasyForm. So where might you want to use this? Well, if our bet is right, it will be in places where there are high volume applications, so that the cycle time is a big payoff, where the reduced centering and tilting time will allow a lot higher capacity and number of parts that can be run per shift or per day. Another case might be the 80 kilos of payload capacity. Even if your part's not that big, let's say you have this great big, somewhat heavy part, but it kind of looks like Swiss cheese and it's got all these holes in it. But you need to measure in all those holes, and you got some complicated fixture that allows you to move the part around and measure in all those holes. Well, maybe the combination of that fixture and that part starts to get to be too heavy for some of the traditional form testers. Well, maybe this is a good application for an MMQ 500. And finally, wherever the tighter specifications are, then you might find that where the MMQ 400 was borderline in the past, the MMQ 500 could meet the requirements today. Thanks for taking the time to attend today and find out more about this. Thank you.